So welcome you all to the last lecture of this section and this course. So in this lecture we will learn about the whirling speed of shaft. So let me plot the arrangement for this thing. So this is a rotor. It is mounted to shaft, and this is the center line passing through the shaft axis. You can say that this is the heavy side of the rotor and this is the lighter side of the rotor. So this is rotor, and the force acting will be, when it is rotated, the force acting will be like me omega square. So this point is called S, and this point is Z, and the distance between S and G point is E. So E is the distance here. And it is rotated with some angular speed omega. So if it is moving along this direction, then that is y is greater than 0 and we constant is positive in nature, and if it is moving in this side, it is that is y is less than 0 and we take it as a negative. So here shaft is massless and damping is absent. There is no damping in this case, and m is equal to mass of the rotor E is equal to the eccentricity of rotor. G point, that is this point G is the center of mass of the rotor, because this is heavy side, and O is equal to point exist on axis of rotation. So this is some point over here. So this is the point which exists on the axis of rotation, that is the axis passing through bearing centers, and here the S point, that is this point, S is the point existing on centroidal axis of the shaft, and Sg is equal to the eccentricity, that is Sg, difference between S and G point, and we should consider let me raise this thing first. here K is equal to transverse stiffness of shaft. Now moving to the main thing. Now if this shaft like this shaft starting that if the rotor starts rotating, so it will look like mirror this thing. So the diagram will look something like this thing. This is the initial axis, and the rotor will move in this direction slightly from its initial position, and this is the shaft. This is the rotor. So this is the axis of, this is the green line is the axis of rotation, and in this case that is it is moving towards this point, it is y greater than 0, so we'll take it as a positive. And due to this this is the S point, and this is the G point, and the distance between these eccentricity, that is E, and from this point to this point there is some displacement, that is Y, that is this is the O point lying on the axis of rotation. And on counter the force acting on the center of mass, that is on G point, is the m equal to y plus e omega square, and counter force is acting is ky, the counterbalancing force. So at equilibrium position, resistive force is equal to the centrifugal force. So this is the centrifugal force, and this is the resistive force. So resistive force is K into Y equal to the centrifugal force, which is m dot E plus Y dot omega square, and for the simplifying, that is Ky minus m y omega square is equal to m E omega square. So taking y common, we are going to get K minus m omega square dot m E omega square, and we will be getting y equal to m E omega square divided by K minus m omega square, and dividing the numerator and denominator by let me erase this thing first, sorry. Now dividing the numerator and denominator part by m omega square, we are going to get let me erase this thing first. So we are going to get y equal to m E omega square divided by m omega square by K by m omega square minus 1, and after further simplification we are going to get the y equal to E upon eccentricity upon omega n by omega square minus 1. So this is the equation of our interest, which marks the end of this lecture and this course. So thank you for watching this course. Hope you have enjoyed it, and for any doubt just message me now. Thank you.